Hey all, this is Tucker with Higher Blue. Today we're going into another NATE core exam discussion on construction math. More specifically, we're going to be focusing on trigonometry today. We covered geometry and fractions in previous videos, so be sure to check those out before you go into this one because the topics do build on top of each other. So really trigonometry is just an intimidating word for the study of angles and triangles. If you're familiar with measurements that have to do with angles and triangles, you're already on your way to being an expert in trigonometry. There's really not much to it. There are some basic laws and rules we need to understand in HVAC, but also in the construction industry as a whole. So an HVAC technician works with angles and triangles often for a variety of reasons, mainly when they're interpreting schematics, blueprints, and ductwork designs. Sometimes technicians need to actually sketch out rooms and buildings, which does require knowledge of angles and triangles to draw those accurate scale measurements as well. So let's dive in, starting with angles, and then we'll go into triangles after that. Okay, so what is an angle? An angle is a basic concept that is apparent in many parts of everyday life. Simply put, an angle forms where two lines intersect. So the spokes on a bike, an edge of a table, two perpendicular walls intersecting. These are all examples of objects that have intersecting lines that form angles. Angles are measured by the size of the opening between the two lines and are measured in degrees. If you look on this slide, degrees are expressed with this superscript circle right here. And so when you talk about an angle, it's always going to be talked about with degrees. So a 90-degree angle, 180-degree angle, etc. So as we talked about in the construction math geometry section, angles denote the rotational direction of a circle. So a circle lies on a two-dimensional plane where two lines intersect each other to form four 90-degree angles. And overall, a circle is 360 degrees. So there are 360 1-degree angles within a circle. And it's intuitive, but as the opening of the two lines that intersect get bigger, the angle gets bigger. So imagine if you have a book that's completely closed, the two bindings won't be forming any angle. The angle will be 0 degrees. But as you begin to open the two bindings of the book farther and farther apart, the angle between the two bindings gets bigger. So there are a variety of angles and I guess definitions of angles that we're going to cover. I'm going to just pull all of these up here, but basically we want to cover obtuse, acute, right, and straight angles. All are very important in construction and all have slightly different meanings. So the right angle is over in the top left of this chart, and the right angle is an angle where two lines are perpendicular and form 90 degrees. That is probably going to be the most important angle when it comes to trigonometry because the right angle has all these immutable laws associated with triangles that have a right angle. There are also obtuse angles. Obtuse angles are any angles that are greater than 90 degrees. So in this example over here, this angle actually is 270 degrees, meaning it's obtuse. And then acute angles are any angles less than 90 degrees. So on the bottom left here, this is an example of a 45-degree angle where the opening is smaller than 90 degrees. And then finally, we have a 180-degree angle or a straight angle. So if you notice up here, we have a 90-degree angle and a 90-degree angle. When added together, it actually forms a straight line, which is a 180 degrees. So similar to the 90 plus 90 degree angle example I just showed, you can add and subtract, divide angles as well, just like you would for any normal mathematical formula. So in the example here, we have a 45-degree angle plus a 60-degree angle. So all we're going to do there is add 45 and 60 together to get 105 degrees. So this is just an example of taking two acute angles, 45 degrees and 60 degrees, adding them to form a obtuse angle or an angle that's greater than 90 degrees.